dear students, welcome to Easy BTech, your guide for BTech and beyond. Our subject signals and systems, and today's topic properties of Fourier transform, very important topic. And before going to our important topic, all of you subscribe, share the channel. This channel is very helpful to you. Let's start our session, today's session, properties of Fourier transform. So in the previous session already we have covered 4 properties, okay, linearity, time shifting, time scaling, okay, time reversal. Let's now see remaining properties. Frequency shifting. This property is now frequency shifting. Frequency shifting. Frequency shifting property. So all the properties are first defined, then we are doing proof. So all properties proofs with the help of Fourier transform formula only. So first see the definition or statement. If x of t Fourier transform is x of omega. Now what is the property? Frequency shifting. Now I am shifting the frequency, means x of omega minus omega naught. X of omega minus omega naught. So this is x of t into e to the power j omega naught t. So if you multiply the signal by exponential j omega naught t, then its Fourier transform will become x of omega minus omega naught. Let's see the proof of this property. So all proofs with the help of Fourier transform formula only. So write that Fourier transform formula. X of t Fourier transform is capital X of omega is equal to integral minus infinite plus infinite x of t e to the power minus j omega t dt. This is the Fourier transform of x of t. Now I am going to take LHS. What is the LHS in the second line? This is the LHS, left hand side. So I am going to write now Fourier transform of x of t into e to the power j omega naught t. E to the power j omega naught t. So how to write this Fourier transform? As already we discussed, whatever the signal that is in the x of t place. So here we have x of t into e to the power j omega naught t, right, into and e power minus j omega t, e power minus j omega t dt. So here we have 2 exponentials, right? So we are going to add powers, that is the next step. So integral minus infinite plus infinite x of t e to the power I am taking minus j is common. Then here we get omega minus omega naught and t also common, dt, right or not? So by comparing this integral with the Fourier transform integral or Fourier transform formula, just do comparison, we can get the answer. So what we have by comparing it? So here we have omega, that is why it is capital X omega. Here we have omega minus omega naught, everything is same, but omega minus omega naught. Therefore, the answer is capital X omega minus omega naught. In the same way, suppose if we have plus, here we have plus x of omega plus omega naught. What you can expect here left side? Minus j omega naught t, e power minus j omega naught t into x of t. So that line I am writing. So finally x of t into e to the power plus j omega naught t. First we write plus j omega naught t, then we write second one minus j omega naught t. So x of t into e to the power j omega naught t Fourier transform is x of omega minus omega naught. X of omega minus omega naught. But similarly, x of t into e to the power minus j omega naught t. What is the answer for this? Here minus j omega naught t. So then you get here x of omega plus omega naught. So very simple. Okay. So this is the frequency shifting property. Next we go to duality property. Very important. Duality property. Duality. So first we discuss what is duality, then we do proof. Okay. So this is the statement or definition. If x of t Fourier transform is x of omega, then you take this capital X of and omega is replaced by t in the place of omega t. Then the result you get is 2 pi into small x and t will become minus omega. So 2 pi into x of minus omega. This is the duality property. Let's have proof for this duality property. Okay. So for proving duality property, we consider inverse Fourier transform formula. Inverse Fourier transform formula. So we know that inverse Fourier transform of x of omega is equal to small x of t is equal to 1 by 2 pi integral minus infinite plus infinite x of omega e to the power j omega t d omega. So this is the inverse Fourier transform formula. For duality property proof, we consider inverse Fourier transform formula. Now in the place of omega replace, in the place of omega I am going to replace omega by x. In the place of omega we are writing x. Then what happens? X of t is equal to 1 by 2 pi integral minus infinite plus infinite capital X of x e to the power, and here also omega, so e power jx t, and here d omega, it will become dx. Okay, just omega is replaced by x. So this is the first step. And in the second step, so I am going to replace t. So t I am going to replace by minus omega. So in the place of t we are writing minus omega. That we are going to see. So by writing t is minus omega, what happens? So in the place of t, minus omega. So x of minus omega is equal to 1 by 2 pi. Here we have here minus omega. So 1 by 2 pi integral minus infinity to plus infinity. Okay. Capital X of x e to the power. Here t is minus omega. So minus j x omega dx. Right. Now this 2 pi I will send left side. So it will become 2 pi into x of minus omega is equal to only integral minus infinite plus infinite capital X of capital X of x, capital X of small x, here capital X of small x e to the power minus j omega x dx. Right. Now I am going to replace third step. I am going to replace x by t. So in the place of x, take t. This is the third step. right? 1 2 3. So in the third step we get the answer. So x place is t now, x is by t. So now left side we have 2 pi x of minus omega is equal to integral minus infinite plus infinite capital X of t into e to the power minus j omega t dx, it is dt, right? So now if you observe right hand side integration or integral, so it is like our Fourier transform formula. What is Fourier transform formula? Fourier transform formula, what is it? Fourier transform of x of t is equal to x of omega is equal to integral minus infinite plus infinite x of t e power minus j omega t dt, right? So this integral is also same like Fourier transform formula. Just compare these two. So this is the Fourier transform of x of t, that is x of omega. Now this is the Fourier transform of what? What it will be? Is equal to Fourier transform of capital X of t. Right or not? That is the answer we got. So finally we can write like this using pair. So Fourier transform of capital X of t is equal to, or 2 pi into x of minus omega. So very important. Just 3 steps. Omega is replaced by x, t is replaced by minus omega, and finally x is replaced by t. Right? Duality property. Very easy and important. And next we go to another property, time differentiation property. The property time differentiation property. Time differentiation property. Time differentiation property. So it is also important. So first we see the definition, then we do proof. So first definition is, if x of t Fourier transform is x of omega. So this is time differentiation, means d by dt of x of t. Differentiation of x of t with respect to t, time. So it will be how much? Fourier transform of d by dt of x of t is equal to j omega into x of omega. So one time j omega is multiplied by x of omega. See the proof. So first we have Fourier transform formula. So do that, take it. Fourier transform of x of t is x of omega is equal to integral minus infinite plus infinite x of t into e to the power minus j omega t dt. Right? This is the Fourier transform of x of t. Right? And we have inverse Fourier transform formula. Here also I am using inverse Fourier transform formula. So what is the inverse Fourier transform formula? Inverse Fourier transform of capital X of omega is equal to small x of t is equal to 1 by 2 pi integral minus infinite plus infinite capital X of omega e power j omega t d omega. So inverse Fourier transform is useful to do the proof time differentiation property. So let's consider this x of t and do the differentiation both sides. So differentiation both sides x of t with respect to t. So d by dt of x of t is equal to d by dt of 1 by 2 pi integral minus infinite plus infinite x of omega e power j omega t d omega. So if you observe here clearly, right side, differentiation is there and integration is there. So integration is with respect to omega and differentiation is with respect to t. They are not same, different. Clear? That is a point. So that is why next step is 1 by 2 pi integral minus infinite plus infinite x of omega. So differentiation is with respect to t. So here we have e power j omega t. So differentiation is for e power j omega t. That is why I am writing d by dt of e power j omega t and the remaining d omega. Understand it? So differentiation is only for, with respect to t. So t term e power j omega t. That is why d by dt of e power j omega t. So perform this differentiation, then we can get the answer. So now differentiation c is equal to 1 by 2 pi integration minus infinite plus infinite x of omega into differentiation of e power j omega t. It is same e power j omega t into j omega, right? In the power we have j omega and d omega. Okay, so now we can write this as, just I am rearranging, 1 by 2 pi integral minus infinite plus infinite. So I am going to write like j omega into x of omega into e to the power j omega t d omega. Now you observe this integral carefully. Just observe this integral carefully. We can get the answer now. So just observe this integral. So this integral is a inverse Fourier transform, right or not? This is the inverse Fourier transform. Same. But here instead of x of omega we have into j omega also there. So that is why I can write d by dt of x of t. We can write as d by dt of x of t. D by dt of x of t is equal to inverse Fourier transform of, whose inverse Fourier transform it is? J omega into x of omega, right or not? Just observe the inverse Fourier transform and the integral what we have. By comparing these two, we get inverse Fourier transform of j omega into x of omega. So therefore, what we can write finally? What we can write? So d by dt of x of t Fourier transform, d by dt of x of t Fourier transform is j omega into x of omega. Very, very important. For example, if you have second time derivative, x of t second time derivative, what happens? That means, first I write again, d by dt of x of t Fourier transform is becoming, its Fourier transform is j omega into x of omega. I am just keeping brackets for j omega for clarity. So d square dt square x of t Fourier transform. It is Fourier transform type. So d square dt square x of t Fourier transform will become, yeah, j omega whole square x of omega. Likewise, d power n dt power n x of t Fourier transform will become j omega power n x of omega. Is it right? So very, very simple and important. This is the time differentiation property. So similarly, we have frequency differentiation property. Another property, frequency differentiation property. Frequency differentiation property. So first see the definition, then see proof. Frequency differentiation property. So let's take definition first, or statement. If x of t Fourier transform is x of omega, then frequency differentiation means d by d omega of x of omega. This is the frequency differentiation. So what happens? D by d omega of x of omega is equal to minus jt x of t. So x of t is multiplied by minus jt. If you do frequency differentiation, our x of t is multiplied by minus jt. So let's see the proof. So proof is from Fourier transform definition only. So what is a Fourier transform? Fourier transform of x of t is equal to x of omega is equal to integral minus infinite plus infinite x of t e to the power minus j omega t dt. So let's take this part, d by d omega of x of omega, and means x of omega is differentiated with respect to omega. So d by d omega of x of omega is differentiated with respect to omega is equal to d by d omega of this total integral minus infinite plus infinite x of t e to the power minus j omega t dt. Right or not? We are taking differentiation of x of omega with respect to omega, that I written. So if you observe here again, here we have integration and differentiation, both are there, but differentiation is with respect to omega and integration is with respect to t. They are not same, different. So don't think they are cancelled. So they are different. So how to do it is integral minus infinite plus infinite x of t. Here e power j omega t is there, omega is available in e power j omega t minus j omega t. That is why differentiation is only for that e power minus j omega t. So that I am writing d by d omega of e power minus j omega t dt. Right? It's clear. So do the differentiation of this. You can keep bracket for clarity. So differentiation of e power minus j omega t. What is now? Integral minus infinite plus infinite x of t into same e power minus j omega t and minus jt. Right or not? Differentiation is with respect to omega. So minus jt dt. So all are t terms, no one will go out. Then just I am rearranging like this, rewriting. So this is equal to, we can write like integral minus infinite plus infinite minus jt into x of t into e power minus j omega t dt. So now this integral again compare with Fourier transform integral. Compare this Fourier transform integral and this integral what we have. Then we get the answer. So do the comparison of these two integrals. Compare. So this is the Fourier transform of x of t. Here we have Fourier transform of minus jt into x of t. Right or not? So by comparison, Fourier transform of minus jt x of t is equal to d by d omega of x of omega. So this we can write like Fourier transform pair using arrows or arrow. So minus jt x of t Fourier transform is d by d omega of x of omega d by d omega of x of omega. So very very important, this is also. Okay. So time differentiation, frequency differentiation. Next property, time integration. This is also important. Time integration. Time integration property. See the definition, time integration. If x of t Fourier transform is, if x of t Fourier transform is x of omega, capital X of omega. Now time integration means integration of this x of t. So integral minus infinite to t x of tau d tau, x of tau d tau. So this will be x of omega into 1 by j omega plus pi del of omega, pi del of omega. Here I am just multiplying this x of omega by j omega plus pi x of omega into del of omega, right? So del of omega and x of omega, they are multiplied. So what the result, I am discussing these two, this multiplication I am discussing. So then we have x of omega by j omega plus pi x of 0 into del of omega, x of 0. What is x of 0 actually? X of omega at omega is equal to 0, that is x of 0, right or not? This means x of omega at omega is equal to 0. For example, this x of 0, if x of 0 is equal to 0, the value of this x of 0 is 0. Then what happens? The result is, what is the result you get? X of omega by j omega you get. Okay, x of omega by j omega. So let's see this proof. This is only statement. Go to the proof now. So this property is proved with the help of convolution property. So here this we can do using convolution property. So this convolution property we can discuss later. So convolution property, using convolution property. So I am going to take convolution of x of t, u of t. Okay, convolution of x of t and u of t. So this convolution we can write like this integral minus infinite to t x of tau d tau. Okay, so the integral represents convolution of x of t, u of t. This integral convolution of x of t, u of t we can discuss later, but in this property just we are going to use this for the proof, only for the proof. So the integral we can write like x of t convolution u of t. So if you apply Fourier transform, so Fourier transform of x of t convolution u of t, x of t convolution u of t is equal to Fourier transform of this integral minus infinite to t x of tau d tau, x of tau d tau. So what is the convolution property? Here I said convolution property. Okay, the convolution property says that convolution in time domain equal to multiplication in frequency domain. Convolution in time domain is equal to multiplication in frequency domain. Multiplication in frequency domain. This is the convolution property, frequency domain. So as per that, I am going to next step. So Fourier transform of integral minus infinite to t x of tau d tau. This will become multiplication. Here Fourier transform, convolution, Fourier transform and convolution. It will become multiplication in frequency domain. So x of t is x of omega and into multiplication, that is why into u of t Fourier transform. Already we discussed this u of t Fourier transform 1 by g omega plus pi del of omega. Right or not? X of t Fourier transform, x of omega, u of t Fourier transform 1 by g omega plus pi del of omega, both are multiplied. That is a property we have, convolution property, right? So if you send x of omega inside, then we have answer, right or not here? So that's all. So we can write x of omega by g omega plus x of omega into del of omega into pi. So already this discussion we have here. So this will become x of 0 into del of omega, and x of 0 is 0. If x of 0 is 0, then we get, what is the answer we get? 1 by j omega, x of omega by j omega. This is the clarity. So Fourier transform of integral minus infinite to t x of tau d tau, integration in time domain, this is equal to x of omega by j omega, x of omega by j omega. Okay. So still we have properties, Fourier transform properties, convolution property. Okay, that we can discuss later. So thank you students, we'll meet again.